Alright, hey, what's up, guys? I wanted to make a couple calc videos to help explain to a friend, uh, some calc problems because I know they're struggling and calc is really hard, especially for your first time. So I'm gonna make a couple videos, every so often to help the entirety of a group, and hopefully these videos will be helpful. I know that right now there's a pandemic going on, so you're probably not getting as much instruction as you want or as you need. So, yeah, that's why I'm going to be making these. If you have any questions, email me or comment. Commenting is probably best so I can pin your questions. So if other people have problems or issues, you can just, you know, read off of theirs and my answer will be there. Alright, so the question we have here is, in the figure, line L is tangent to the graph of y equals 1 over x squared at point P. So we know that L is tangent to P with coordinates w 1 over w squared. So we know that P is w 1 over w squared. And w is just the same as x. It's given that 1 over x squared is the y, and we see that 1 over w squared is basically the same, and we see that this is going to be the x coordinate, so we just plug in w for x. So w is the same thing as x, where w is more than 0. And the reason why w is more than 0 is because if you plugged in 1, or if you plugged in w for 0, or if you plugged in 0 for w, my fault, you would get undefined or infinity because you just cannot divide by 0. Point Q has coordinates w 0, so we know that this means that this is an x coordinate. This is w 0, and line L crosses the x-axis at the point R, so with coordinates k 0. So this is k 0. All right. So let me pull up the problem here that we're going to be tackling right now. Alright, so with that, the problem we're going to be facing is find the value of k when w equals 3. Okay, so what it's assuming is point P is going to be determined by w equals 3, so the x value is going to be 3. So first thing I'm going to do is I'm going to write down the problem we have, or the function we're using. So 1 over x squared is the function of the line right here. So I'm just going to place that right there. This is just, for me. I also know that 1 over x squared is equivalent to x negative 2. This might make it easier for finding the derivative because what's going to be asking us is to find what r is after finding the tangent. This question is asking us to find the 0 of the tangent at point P. Hopefully that sounds a little confusing right now, but hopefully as I explain this here, it'll make a bit more sense. So f prime of x, we know how to solve this. We're going to multiply by negative 2, and then we're going to subtract 1. So negative 2x, negative 2 minus 1 is negative 3. So negative 2x, negative 3. This is the derivative. So I'm just going to get rid of all this so we aren't getting confused. Equals negative 2 over x3. Because the x was negative here, we can just bring the x to the 3 to the bottom. You can see that same operation right here where we brought the x up. If we wanted to bring it down, we would just do 1 over whatever this is. So negative 2 over x3. So now that we have that, I'm going to find what the coordinates of P are. So P is, we have 3, and then we have 1 over w squared. We know we know 3 squared is 9, so 1 over 9, and we know that w is 3. So that's how we have point P. So that's going to be 3. for this, and now we can actually plug in some things. Because we want to find the instantaneous rate of change at P, we're going to plug in, or at 3, which is W, we're going to plug in 3. So f prime of 3 equals -2 times 3, or divided by, my fault. 3 to the 3 is 27. 27. So now we have -2 over 27 is the instantaneous rate of change. This is the rate of change of the tangent. So that does not account for where the tangent is positioned. If you were to graph this at -2 over 27x, it would be placed right here because you haven't actually defined where this is. So what we're going to do now that we have the slope of the tangent is we're going to plug it in, and we're going to find the equation that will make this line tangent to P. So we're going to make sure that it just touches. A very easy way to do this is to just take this, or is to actually refer to, I believe it's called Taylor's form, where it's y equals m x minus x1 plus y1. So we're going to plug each of these in. So we know the slope here, so we're going to plug it in here. Then we're going to plug this in, 3 right here, and then we're going to plug this in right here. So now we have the equation y equals -2 over 27 x minus 3 plus 1 over 9. And once again, we're doing this so we can position the tangent to be position this line to actually be tangent to P. So if you were to graph this on Desmos or something, this would just touch. So now that we have this, we're going to find where R is. So we know R has a Y value of 0. It's given there. And we also know that we're trying to find the X-Intercept, which is R. That's what this is how it was given. Crosses the X-axis at point R with the X-Intercept. So all we have to do is plug in Y to be 0, and then we just solve. So -2 over 27, x minus 3, plus 1 over 9. First thing you're going to do, subtract 1 over 9, minus 1 over 9. So then we have -1 over 9 equals -2 over 27, x minus 3. What I'm then going to do is divide by 2, -2 divided by 27. And when you divide a fraction, you just flip them and then you multiply. So we're going to have -1 over 9 times 27 over -2. So we know -18, and then -1 times 27, -27. If you know your multiples of 3, you'll know that this is actually equivalent to 1.5. So 1.5 equals x minus 3. Then you're just going to add the 3 plus 3. 4.5 equals x. And that is going to be k. So k equals 4.5 when w is 3. There you go. I hope that wasn't too confusing. I'll be doing another problem with this same I'll be doing another question with this same set of information, and I'll upload that in a different video. Yeah, later.